All right, we're going to look at some problems that involve transformations with absolute value functions. So these are actually two of the problems from our notes today that we didn't cover. We just did the first four. So if you want to do the two on your own, you can check your answers against here. So what I'm going to do first is I'm going to factor a 2 out. And that leaves me with x plus 1. And so that's going to help me in terms of identifying transformations. Okay, so the plus 2 will move it up 2. The x plus 1 will move it left 1. The 2 on the inside is a horizontal shrink by a factor of 2. The 2 on the outside is a vertical stretch by a factor of 2. And you could see combined, you can actually look at this as a vertical stretch by a factor of 4. And then the negative is a reflection about the x-axis. Okay, so our transformation, we go 1 left, 2 up. And finding other points, I'm going to substitute 0 for x and find the y-intercept. So that is a 0. Absolute value of 2 is 2 times negative 2 is negative 4 plus 2 is negative 2. And we know we have a symmetric point on the other side. And so now we can graph those two halves of our absolute value graph. All right, so we need two more things. We need domain and range. So domain, we know all real numbers, or negative infinity to positive infinity. And our range here is the uppermost portion, the greatest y value. So it's going to be y is less than or equal to 2. Okay, and then finally rewriting this as a piecewise. So remember our argument, 2x plus 2 has to be greater than or equal to 0. So x is greater than or equal to negative 1. So that means that when I rewrite this as a piecewise, that for all values greater than or equal to negative 1, our argument is positive, so we don't need to change anything. But for anything less than negative 1, the argument will be negative. We need to multiply this by negative 1, so that leaves us with a 2 times 2x plus 2, and then another plus 2. So again, looking at setting our argument greater than or equal to 0, that means if I substitute negative 1 in for x, we're going to get 0. The absolute value of that is 0. And then any number greater than negative 1, this will be positive. And if our argument is positive, then the absolute value symbols don't change anything. Anything less than negative 1, so like say negative 2, the argument is going to be negative, and the absolute value will make it positive. Another way to do that is to multiply that by a negative number. And so now we're going to clean that up a little bit. So distribute, we get negative 4x minus 4 plus 2 is negative 2. And here, clean that up, 4x plus 4 plus a 2, 4x plus 6, for x is less than or equal to negative 1. All right, let's look at one more. So again, we're going to factor out that negative 3, and we'll see in a few minutes that changes some things as well. So we have a negative 3, and then x minus 2/3, right? We factor a negative out, that changes sign. Oh, my focus is, let's lock that in there. Okay, let's see. Let's autofocus. All right, let's see. I can see on the screen here where, okay, that's focused. Now we want to lock that. It's not focusing correctly. I'm going to try something here. Sorry for the delay. We're trying to get this back into focus. It was locked. All right, let's see if that helps. Okay, so with our transformations, so x minus 2/3, so that goes to the right 2/3. That 3 is a horizontal shrink by a factor of 3, and the 2 on the outside is a vertical stretch by a factor of 2. Okay, so we're 2/3 to the right. We're not up or down, so we're right here. And that leads us, a little bit of an approximation there, right? Because we don't have an integer coordinate there. I'm going to find the y-intercept. If I plug in 0 for x, absolute value of 2 times 2 is 4. And because I went 2/3 that way, I'd go 2/3 this way, which is 1 1/3. Okay, so now we've got our 2/2 to be able to graph. All right, our domain, again, all real numbers. Range, y is greater than or equal to 0. We didn't move it up or down. And let's see if we can lock that. I apologize, I can't figure out why this won't lock. All right, so now in terms of our rewriting it as a piecewise, again, we're going to take our argument and notice what happens here, right? As long as the argument is greater than or equal to 0, we don't need absolute value. So if I subtract 2, and when I divide both sides by the -3, right, we reverse the inequality symbols. So now this is positive for values less than or equal to 2/3, right? Normally it's a greater than or equal to, so a little different here. So we have 2 times -3x plus 2 for x less than or equal to 2/3. And if we substitute a number greater than 2/3, then inside our absolute value, our argument will be negative, so we need the opposite of that. So this will give us a -6x plus 4 for x is less than or equal to 2/3, and a 6x minus 4 for x is greater than 2/3. So again, this -6x plus 4 is this portion up here for x is less than 2/3, and then the 6x minus 4 is this portion here when x is greater than 2/3. Hope that helps, and we'll see you soon.